So we are live. So hey guys, this video is about a coding question. So I think I'll be starting a series where I'll tackle various competitive programming questions. I'm not an expert at it, neither am I good at it. This is basically the first ever competitive programming question that I'm attempting. I mean, I have attempted competitive programming before, but basically like a few questions that are required to pass the DSA exam. That's it. So this is my first ever serious competitive programming attempt where I'll be logging each and everything, where I'll be making notes, seeing various alternate methods which are better, and that will increase my time and space complexity. So let's get right into it. So the first question, as you can see over here, is count odd numbers in an interval range. Given two non-negative integers low and high, return the count of odd numbers between low and high inclusive. Okay. So let's go through the example. Low is equal to 3, high is equal to 7. So number of odd the odd numbers are 3, 5 and 7, both low and high included. That's right. And over here it's 9. So this is the solution that I came up with in like 5 minutes before starting this video. As you can see, it's pretty simple. I set a count variable, start a for loop where I put a range of low and high, where low and high are the variables of this or the parameters of this function. So low and high plus 1, since range is not inclusive of the upper value, so high plus 1. This also I didn't get right the first time. I set this variable to high only, and then I came to know that it doesn't include the higher part of it. So, and then check whether number is odd or even. If it's odd, then it shouldn't be completely divisible by 2, and so it will not give 0. That's right. And count is equal to count plus 1. If it's odd, then it will count the number in, increase the counter by 1. It will go through the loop again, and if it's odd again, then it will increase, and so on and so forth. If I run the code, it passes all the test cases. What is these? I don't know. And if I submit, as you can see from my previous submission, that is the same submission, the memory limit exceeded. This means that this is not an efficient solution, and LeetCode was expecting me to do something more efficient. Hey guys, editor Rohit this side. Solving this question took me a long time, so most of the content in the next few minutes are fast forward. But let me just give a commentary of what's going on the screen. So here I am checking through the Wikipedia page of parity, what parity is, going through the hints again and again, checking Geeks for Geeks for some parity related information, using Google Calculator to check the test cases, still doing mental math, not using a proper notebook or an editor to write down the test cases, form various cases and then solve the problem. But soon you'll realize that my pea-sized brain is not able to do that, and I'll start using the Sublime editor. Here I am using the Google search bar to form the test cases and see how it satisfies the range equation. Finally open the Sublime editor. Finally. Again and again going through the parity equation, checking other sources like Wolfram, MathWorld for parity. Here I got the main idea of what parity is about. There are two kinds of parity. One is odd and even parity, basically whether the number is odd or even. Second kind of parity is it's basically in the binary representation where we count the number of ones in it. If the number of ones are if the number of ones are even, then that's even parity, otherwise it's odd parity. So for this problem I soon realized that we do not have to check it in binary representation on it. We only have to know whether the high and low numbers are even or odd, and that will decide whether I have to take the seal of the equation or the floor of the equation or do nothing. So all of this took me quite a long time. Like for me, I expected that I would finish this YouTube video finish solving this question in maybe like 10 minutes. The video will be 8 minutes long, but I finished recording this video, or logging the whole process took me more than 2 hours. So I thought it would be a better idea to just fast forward the whole process and then do the commentary and then resume with my final conclusion. Now coding the ending part of my optimized solution, doing all the saving and stuff. Okay, back to the video, Rohit. So this is where we at. This is the solution that I came up with, checking the first condition where the range between high and low is given by this expression. If it's even, then the number of odd and even numbers would be the same. So we just divide this range by 2 to get the odd numbers. Second is what if it's not even? Then it depends upon the odd and even parity of high and low. And to figure that out, we used different test cases which are given over here. Okay, these were the cases that I came up with. Different parity but both are odd. Different parity, one is even, one is odd. Different parity, both are even. Same parity, one is even, one is odd. Same parity, both are odd. And same parity, both are even. We also realize that both in all of these cases, the parity where we count the number of ones in the binary representation does not matter. Only the odd or even, whether high and low are even or odd, matters. So we can observe that case 1 and case 5 where both are odd, we have to take the seal. Case 3 and case 6 where both are even, we have to take the floor. And for case 2 and case 4, nothing is to be done to the expression, as we have equal number of odd and even numbers in that range. That means the number of values in that range is even, so the number of odd and even numbers are equal. So to take account of that into this code snippet, we will check whether high and low are even. If they are even, as discussed before, we will take the floor of this expression. And if they are not even, if they both are odd, we'll take the seal of this expression. And if we submit, we get the following solution, where it says that it's 67.15% faster than other Python online solutions, but it takes a lot of memory, that is 13.6 MB, which is less than 10.58% of the Python online submissions for counting the odd numbers in an interval range. Now let's check out the most efficient solution that I found on this website, which was given by Yaroslav Repeta. So high minus low plus 1 is the number of elements between high and low, where half of them are odd. So high minus low plus 1 integer division by 2. So here this guy has used an integer division, and to confirm what integer division does is, for example, take 3 divided by 2, it prints 1.5. But if we do an integer division, it will take the floor automatically and print 1. And as I suppose this is an inbuilt functionality in Python, and we do not have to import any extra libraries that are like I did for my solution. Over here I imported maths library for the floor and seal function. This itself might have increased the time complexity. So if we use inbuilt Python operations like integer division, it would kind of reduce the time complexity by some level. Now let's check out the solution over here, and additionally add 1 if high and low are odd for case when there are more odd numbers than even ones. So he also considered, it seems that he also considered similar test cases like us, but his solution is much more efficient. So high minus low plus 1 integer division by 2 plus high %2 and low %2. So let's take a test case over here for this. What if we take, if we specifically want to check for both odd numbers, we'll take 11 and 7, right? And what is the answer over here? Both are odd, we get 3. So this works fine, and plus this is much more efficient. The reason why it's much more efficient is because it uses inbuilt Python operators, and there are significantly less number of, there is no if else statement, unlike my solution over here where it has to again and again check conditions for it. So now what I came up with is, as I am uploading the YouTube video, I'll also mention a link for my Notion notebook where I am taking note of the problem over here, problem description, my first solution, my unoptimized solution, and the problem with it, memory exceeded because of the simplistic nature of it, which was very inefficient. It had to loop again and again to check whether the individual number is odd or even. My optimized solution, and finally the test cases for the above solution, and finally the most optimal solution, heading most optimal solution, which is this one, right? Yep. And once I upload this video, I'll in the description I'll give the link for this Notion notebook and for the GitHub repository where I will upload other solutions, other coding problems that I tackle during these 30 days, or maybe more than that, we'll see. So thank you guys, and this is it for this video. Check out my other videos, as well. See you next time.